Vanakkam. In the previous sessions, we discussed the parameters in the MRP1 and MRP2 views and created both views for the business case materials. As the next step, we must create the MRP3 view. In this session, we will discuss various parameters in the MRP3 view and also create the view for a material. Before going to the session, let us see the answers for the quiz we discussed in the previous session. For subcontracting item, what is the procurement type and the special procurement type? The procurement type is F and subcontract procurement type is 30. Special procurement type is applicable only for external purchase items. True or false? False. It is applicable for both purchase and production items. In-house production time is defined in calendar days. True or false? False. In-house production time is defined in working days. Similarly, goods receipt processing time is also defined in working days. What is the purpose of schedule margin key? Schedule margin key defines the floats to be used in planning and scheduling proposal in the orders like float before and after production, opening period and release period. What is the purpose of safety stock? Safety stock is maintained to meet the variations happening in supply and demand. When service level percentage is high, more safety stock has to be maintained. True or false? True. Please note that a 100% service level is almost impossible. Normally, it will be in the range of 80 to 95%. If the service level increases, safety stock requirement also will increase. Backflush can be defined in material master only. True or false? False. Backflush can be indicated in work center, routing, or even in production order. What is the purpose of the production store location field in MRP2 view? If the material is defined as an in-house production item, this field will be the default receiving location for that item from the production. If the material is consumed through backflush, this field will be used as the default issue store location. That is, from there the material will be issued as default. Goods receipt processing time is different for purchase and production purposes for the same metal in a metal master. True or false? False. In a metal master, goods receipt processing time will be applicable same for both purchase and production items. There are no two different goods receipt processing time we can define in one material master. Okay, let us continue the course with a discussion on the MRP3 view. So far, we discussed and created basic data 1 and basic data 2. These are the views organization independent. Then we created purchasing view, that is plant specific. After that, we created MRP1 and MRP2 views, which are plant specific and storage location specific. Now, we will discuss MRP3 view, which is plant specific and storage location specific. So more care must be taken to maintain the parameters in MRP view because these parameters will affect the inventory and also the customer service. There are 4 MRP views in Metal Master. These are plant specific and also storage location specific. MRP1 view contains planning parameters. MRP2 view contains procurement and manufacturing and planning integrated details. MRP3 view contains planning strategy, that is operating model, availability check, and product configuration details. MRP4 contains manufacturing related details like BYM explosion, discontinuation status, production version details, repetitive manufacturing, etc. In this session, we will discuss in detail about the parameters in MRP3 view. MRP3 view contains details related to forecasting, demand management, availability parameters like planning strategy, consumption mode and periods, availability check, replenishment check, etc. MRP3 view has the sections, that is forecast requirements, planning parameters, availability check parameters, and plant specific configuration details. Now we'll see the forecast related parameters. Here we have period indicator. This period indicator is that which kind of period we need to consider for the consumption quantities of forecasting purpose. If it is blank, system takes it as month. Otherwise, day or week may be entered. So this value is taken into forecasting data view. And then fiscal year variant. This is number of posting periods as defined by accounting team. And then we have splitting indicator. This indicator is to split how the forecast requirements have to be split into smaller intervals. Just to see the example what is given here. For the first period, the forecast will be split into daily requirements. That is what is requirement as a number of days as 1. And then for the number second, for the next 2 periods, it is showing us the requirements will be split into weeks. And then in total 4 periods are included in MRP. So please note here for the plant, for the planning indicator and the status what is shown here A. So number of the periods for number of days, periods for number of weeks, and overall periods are given here. So this is one parameter which is normally not used by many people, but if it is used properly, forecast can come out in the right way. And the next important view is the planning strategy view. So this is a strategy group. So here this is how the operation is to be carried out. It is defined in the operating model. For example, when you are using strategy 10, this may be make to stock. When we use strategy 20, it may be make to order. When you use strategy 40, it is a planning with final assembly. Like this, we have different planning strategies. We will be discussing them in detail in the subsequent sections. So demand management aligns sales planning with customer requirements according to the planning strategy, because planning strategy is defined how the demand has to be handled. So planning strategies are defined based on operating models like make to stock, make to order, assemble to order, and engineer to order. Some common strategies which are used in SAP are listed down here. Before going into details of individual planning strategies, let us see the operating models. So make to stock. In make to stock, finished goods are produced and kept in stock. So here lead time is less. It can be delivered immediately. In case of make to order, until we get the order from customer, nothing will happen. Probably components may be available in stock to reduce the long lead time. Otherwise, other activities will not be carried out in make to order situation. In assemble to order situation, we keep the components and sub-assemblies or modular products ready. So the components and sub-assemblies are kept based on the forecast or the or expected stock level, and they will be assembled only after getting the order from customer. So that is the assemble to order, which means we keep component sub-assemblies ready in stock, but we convert them into finished product only on getting order from customer. This week we will discuss about make to stock strategies. Make to stock is an operating model in which production of finished goods is based on forecast or the estimated demand. Some organizations, materials are externally procured as a make to stock item. These are called as procure to stock as PTS. MTS is also called as a push model, as the production happens based on the forecast instead of actual demand. So this is the push method. And success of this operating model depends on the accuracy of the forecast. If the accuracy of the forecast is good, and then the things will be going smooth. If the actual demand is less than the forecast, then accumulation of inventory will be there. If actual demand is more than the estimated demand, it will affect the customer service. In MTS model, the planning is happening for the finished goods, where inventory is kept in the finished goods form. So the lead time will be less. This model works well for standardized products, high and consistent demand products. The advantages are shorter lead time to customer. When forecast accuracy is there, it is a cost-effective model, and also loss of sales will be reduced as there will be enough stock. What is the disadvantage when the accuracy of forecast is not good? Accumulation of inventory will be there, increased inventory cost will be there, reduced customer service also will occur. What are the strategies used in make to stock? Strategy 40, 30, 10, 11, 52 and 63. In this, demand management is applied in all the strategies. Procurement before sales do not happen in strategy 30, and also PR is not there in 30. Sales order is applicable to all the strategies. Procurement after sales is happening in 30, 52 and 63. And a goods issue is happening in for delivery creation, which leads to reduction in PR, is happening in strategies other than 40, because in 40 when you create the sale order, strategy is getting consumed. We'll see that individually all the strategies like 10, 11 and 30, how strategies are entered, how the demands are consumed, so that we can understand this table clearly. For make to stock, commonly used strategy is 10, which is a net requirement planning. This is used for mass production environment and also in repetitive manufacturing. Production is done based on the plan and not after getting the sale order. Major advantage is that smoothing of the production. The planning strategy and relevant parameters are maintained in MRP3 View or the planning strategy 10 and MRP indicator 2. How the process works? In step 1, which is also highlighted in green color in the chart, demand is entered, demand plan is entered. In step 2, production or purchase is carried based on the plan entered in the step 1. In step 3, sale order is created, availability is checked based on the availability parameters, but the sales order does not increase the production or purchase quantity. When the goods issue is done for the sale order, demand plan is reduced as a fourth step. So here decrease in the demand is based on the consumption mode and the consumption period defined in MRP3 View. We will discuss this in a later session. Planning strategy 11 is gross requirement planning. It is normally used in repetitive manufacturing situations where production is planned irrespective of the inventory available. For example, in steel and cement industry, they cannot interrupt the production frequently due to technical and cost reasons. So at that time we use this strategy. So this strategy, when you are using it, the parameters suggested are strategy group 11, mixed MRP2. And how the process is happening? In step 1, enter the demand. In step 2, production or purchase is carried based on the plan, not based on considering the inventory balancing. In step 3, sales order is created. Again, sales order does not increase the production or purchase quantity. When the goods is received from production or purchase is done, demand is reduced. In case of make to stock 10, it was based on the goods issue for sale order, but here it is based on the production receipt. And again, decrease in the demand is based on the consumption mode and the consumption period defined in MRP3 View. We will discuss it later. Strategy 40. This is planning with final assembly. This is used commonly by many companies since the demand will offset against the incoming sales order to adopt the production plan. And when the sale order quantity is more than the plan, system will consider the sales order also in addition to forecast. One way, indirectly it is becoming make to order also in that case. So when you use this strategy, the parameters used are strategy group 40 mixed MRP2. This strategy helps react quickly with the customer requirements. How it is works? The demand is entered through MD61 and PAR, and the production or purchase will be carried out based on the PAR or sales order, whichever is higher. That's what here I told. If the sale order is more, system will consider sale order, so it is a kind of make to order also. In step 3, sale order is created, availability of the metals are checked, and also the sale order does not increase the production purchase quantity if it is less than the plan. If it is more than plan, it will increase. And also when the sales order is increased, whatever the plan is available, that will be consumed. Again, decrease in PAR based on the consumption mode and the period. Now let us understand make to order. Last week we discussed about the last session. We discussed about make to stock. Now we will discuss about make to order. Make to order is an operating model in which the component procurement and production will start after getting customer orders. At the same time, when the make to order is also having another terminology called procure to order, which means if you are buying the materials based on customer order from outside, it is called procure to order. And basically make to order is a pull model. It is a production which is happening at the component stage. It starts with customer demand and it is not based on forecast. So if you produce something with forecast, it is called push model, but here we produce based on customer order, so it's called pull model. Meanwhile, though this is a make to order, to reduce the lead time, some of the components may be planned in advance and kept in stock. This is done with careful and customer coordinated forecast or estimated demand. This is only for long lead items. In make to order model, the focus of scheduling is on raw materials and components as shown in this picture. Make to order works well for low volume products which are having sporadic demand, and also highly customized with more variety products. The advantages are we can produce exactly what customer need as per the specification, inventory will be very less, and also stock obsolescence can be reduced or also avoided. The disadvantages, lead time customer will is more, but it can be overcome by doing efficient improvement in our production processes, and also by having a proper forecast of long lead items. If we keep them, we can considerably reduce the lead time. Cost of products will be on higher side, especially due to economy of scale, because we are producing one per customer based on only the order, so the cost of production may be more. Next variety is called engineer to order. So what is happening in engineer to order? Engineer to order is an operating model in which design and engineering of the products and component itself will start only after receiving the customer orders. And ETO is also a pull model. The difference between ETO and MTO is the MTO products will have design and they are mostly catalog products. But ETO products are not in the catalog, and the entire thing has to be started from the beginning like engineering. ETO models need very close coordination between customer and supplier right from design until installation, involving all functions from both the sides, means customers and suppliers. It needs a very good cross-functional teams. There should be a proper trust on each other, and we should discuss the problems openly, and also there should be mutual support for technical issues, soft skills, training, etc. An engineer to order model works well for a specialized and highly customized products, more complex products. As the design itself starts from customer order, inventory is much less in ETO model. The challenges in ETO model are right from inquiry, design, engineering, and production installation. There should be close coordination required among all supply chain partners and internal functions of each partner. Activities should be planned well, considering resources, skills, dependencies. The collaborative approach of design should be adopted to ensure the designing of product is cost effective and customer friendly. Many revisions may be required. They need to be accommodated with the skill and flexible suppliers and a strong internal manufacturing capability. For made to order or engineer to order, mostly planning strategy 20 is used. When we use this strategy, there is no need of maintaining a planned independent requirement. PIR is not required. The process when we use strategy, the steps involved are the sales orders are entered, the requirements passed to system as a planned order through MRP run or MPS run. The stocks are produced for this order or procured against this order, and they are stored in a special stock type with indicator E. Once the stock is ready, it is invoiced to customer with reference to sale order. Assemble to order is mix of make to stock and make to order models. Components required to complete the finished products are produced, and they are kept in stock based on the forecast. The final production or assembly of the finished products are carried out only after receiving the customer orders. ATO is a push and pull model, as the production and procurement of the components are done based on forecast, but the finished product is produced based on customer order, the real demand. Some organizations call the ATO model as a build to order or make to order, but it is not exactly the make to order. Meanwhile, success of operating model depends on continuous monitoring of inventory of components to ensure availability in right mix at right time and right quantity. The flexible suppliers to support immediately to supply in case of any missing item, and also internal capacity should be enough to produce components in short time to complete final assembly. In ATO model, the focus of planning and scheduling is on raw materials and components or the sub-assemblies. Stocks are kept at this stage. The model is illustrated in the given picture. ATO works well for customized and high volume products, modular based products like computers, laptops, differentiating a product in the last stage of production like a liquid packed product in different sizes like 50 ml, 100 ml or 200 ml, etc. The advantages of assemble to order model are the lead time to customer is less. Variations can be accommodated as the final assembly is done only after the customer order is received. inventory will be less, stock obsolescence can be reduced. The disadvantage of ATO is even if one component is missed to build a product, it becomes MTO and lead to customer loss. Lead time to customer also will increase. Attention to be given to plan the right components and right mix at right time. That is very important point in ATO model. Planning strategy 50 is used for assemble to order. This strategy is used if there is a need to assemble the finished product only after receiving the customer order, but the components may be planned in advance based on forecast. So the strategy 50 is used as a push-pull model. What is push? Push is from the view of planning the components based on forecast. Pull is producing the product only after getting the sale order. In this strategy, the plan independent requirement is maintained either for individual finished products or for planning family, which is a group of materials. What is planning family? What is planning BOM? We'll discuss in the next session. How the strategy 50 works. Demand is entered through MD61 as for a finished product or for a planning material. The production or purchase of components or subassemblies carried out based on the planning BOM or the product BOM depending on the entry what we do for the PIR. Sales order created in system, availability of components are checked, and the sales order do not increase the production capacity but they reduce the demand, the PIR. That's what, when sales order is entered, demand is reduced, final order is triggered. Then based on this, production is produced and the material is invoiced. The decrease in the demand plan is based on the consumption mode and the consumption period defined in MRP3 View, which we will discuss later. While using make to stock strategies like 10, 11 and 40, they are proposing the stocks based on make to stock model, which is a push strategy. When you are using this push strategy, there is a possibility of accumulation of inventory, there is a possibility of stock out. So we don't forecast properly, right? And suddenly some demand is increasing, then we may end up with no stock, so that will affect the customer service. And if we sell less, then we'll end up with more inventory. So to be very careful with this model. This means that forecasting has to be worked out properly, then only we can use this. And also the consumption is happening almost without variation. So that time we can use these make to stock strategies. Make to stock strategies are used for smooth production because we are producing at a constant level, efficiency is improved, capacity utilization is good, so that reduced cost per unit. So this strategy is good for this kind of situation. It is good for operations and manufacturing. Reorder point planning types are also kind of made to stock. Please note that when we use reorder point planning, system will not consider the value entered in the planning strategy field. It will consider only the reorder point value and then lot size related, like fixed lot size means the fixed lot size quantity. If it is maximum stock level means what is the maximum stock we maintain. And while using make to order model, the total system is becoming pull. At the same time, making the full system as a pull is difficult because supply chain, it will create a lot of stress along the system. And also it is not possible to enter the demand or forecast through PIR when you are using MTO model. But we need to have this demand and forecast for two reasons. One is to have long-term resource planning like a plant, manpower or machineries, and also to plan and keep some long lead time materials. To keep these long lead time materials, we have to use like a make to stock or the reorder point for those materials, keep them into the stock. To enable a proper stocking of these components, sales representatives or the sales managers, they should keep in touch with the customers from the design stage of the project or the product of the customer, because this we are talking about make to order or engineer to order, so that we are prepared to keep the components in stock without having much risk. Also, it is important to set the expectations with customer about lead time when you are going for make to order and engineer to order, because it should not surprise the customer later. While using assemble to order, we bring MTS and MTO together, which is creating push-pull model. So due to this, we plan components only and bring down the inventory value, and also the final assembly is done only for the sale order we are getting from the customer. So the components available in stock, they are not restricted to a finished product or restricted to specific customer. It is available, which is good flexibility. Also selecting the push pull point where we are selecting, that's very important. It may be distribution center, it may be factory, and which product point we are selecting it, that's very important. Whatever strategy we take, make to stock, make to order, or assemble to order, we should do complete cost benefit analysis considering overall cost, which is the total cost of ownership, tangible and intangible benefits, because the target for operations is to balance the inventory and customer service. There are strategies like 50 or 60 which are used to implement this push-pull model. Push from view of planning the components based on forecast. Pull from view of producing finished products only after getting the sale order. So for assemble to order, it is suggested to use this strategy with planning with the planning metal. In this case, when you are using planning with planning metal, the plan is entered as a PAR for finished products or for a planning family, which is a virtual material. In case of planning family, a virtual metal will be created as a planning metal and it is filled in the planning metal field in MRP3 view. When we receive the sale order for a customer for a specific product within this family, a PAR of the planning metal will be consumed. How it is getting consumed, we will see. What is the consumption mode, what are the consumption days, we will see in the next session. Components of planning materials are planned based on the planning BOM defined for planning materials. One way to create planning BOM is to arrive based on the weighted average bill of material of individual finished product in the group, which we are explaining now. The planning family, which is here now, F1 is a planning family. And then we are having the finished product like FP1 sold 10 numbers, FP2 sold 15 numbers, FP3 sold 10 numbers. So this is having a BOM for each product. Right? FP1 is having a BOM of component 1, 2, 3. The quantity is 2, 4, 1. And similarly FP2 and FP3 they are in the production BOM as shown here. So the total components used here is to sell 10 numbers of FP1 we used component 1 20 numbers, component 2 40 numbers, component 3 10 numbers. Similarly to sell FP2 15 numbers, we use component 4 20 numbers, sorry that should be 30 numbers, 15 into 2 30 numbers. Component 1 should be 30 numbers, component 2 is 60 numbers. Similarly all the other things also calculated. Now from these we have to get the planning bill of material. How? Consolidate all the individual component consumption, like component 1 is 70 which is coming from here 20 plus 30 plus 20 which is 70. Similarly, component 2 is added, component 3 is added, component 4 is added. So these are the quantities of components used for what? For the sales of 35 numbers of that planning family product. Where is this 35 coming from? The FP1 sold 10 numbers, FP2 sold 15 numbers, FP3 sold 10 numbers, right? That is adding to that, we are getting 35. Now for component 1, we are having this 35 numbers to the product sold, we have used 70 numbers. So the planning coefficient is 2 numbers there. Similarly, component 2 is 100 divided by 35, 2.86. Like this, we are getting the coefficient of BOM for the planning material. So what we do is we enter the planning metal quantity and then we receive the planned order, sorry, sales order for the finished product that is consuming the plan of the planning family. For example, we are entering the plan for family F1 100 numbers. Then system will plan component 1 200 numbers, component 2 286 numbers, component 3 100 numbers. Like that it will plan. So we bring them into stock, but we don't produce the finished products. Once we get the sales order for FP1, that time we start producing it. For example, 10 numbers you receive it. Then the plan of F1 will become 100, no? That will become 90 now. We are having a firm order for FP1 as 10. So now in the system we will see the family 90 numbers, finished product sale order 10 numbers. So the total is maintaining as 100, but now we are getting the firm 10, that planning family 90. So like this, further orders are booked, the plan will be consumed. This is how the planning bill of material is used. And wherever we are having the components which are varying in different BOMs, and there is a non-varying component in BOMs, there is a mix. And most of the places, no, there are common products, common size, common routings when they are having. we can have this kind of planning bill of material and also the planning material concept and apply them. This is giving very good result. I used it practically. It was giving excellent results. So based on that only I suggested and created this session. Here we discussed a very few strategies. These themselves are very powerful and commonly used strategies. We will use mostly 40 in our course, but we will also use some other strategies to demonstrate how they will work. At the same time, please note we cannot explain all strategies in a course. So it is suggested to all of you to revisit these fundamental concepts of make to stock, make to order or engineer to order and assemble to order strategies repeatedly whenever you get any doubt when you are practicing them. Explore various strategies, practice them, how they are working, because any business requirements will need different kind of strategies. There is an answer for almost all the business requirements through the strategies defined in SAP. There is a document which contains the behavior of all the planning strategies. If anyone need the document to go through all the strategies, drop me an email at info@bigrovin.com. I will send it. Now we are going to discuss about the consumption mode and consumption periods. Why do we have these consumption parameters? So we maintain the plan for any material through PIR, planned independent requirement, and they are forecast only. When we receive firm orders like a sales order, or when the make to stock situation we are having this kind of a production orders, then the forecast should be converted into firm orders, which means that the forecast has to be consumed and they have to be taken away from the system. It has to be replaced with the orders. That is the purpose we are maintaining this consumption mode and consumption parameters. So the consumption mode, this defines how the PIR has to be consumed. I mean what direction it has to be consumed. If you maintain the parameter 1, then the PIR will be consumed in the backward direction, and then if 2 means it will consume in backward and then in forward direction. I mean it will act in both the directions, but first it will consume in backward and then it will go for forward. If you maintain 3, it will be consumed in forward consumption. If it is 4 means first it will consume in the forward direction then backward direction. Why are we having this kind of different consumption modes, backward, forward, like this, right? See, there are many requirements from different industries. So there are some companies where we don't want to maintain the past plan, maintain the materials in the past dates, like that. So they will prefer only for forward, or there are some organizations where they will look for consuming the plan in the forward direction. Then, okay, there are some items we can maintain in the backward direction also, I mean the past date also, let us maintain it. So at that time, we can consume the backward direction. So it depends on the criticality of the business and the nature of the business, whether we are going to maintain the plan in the past, so that based on the plan we will keep some materials, or we don't want to maintain any backward, we want to see only forward. So based on these parameters, we need to select the right consumption mode. So we have all the combinations here, as you see. And backward consumption period means how long, right? How many days? This is in working days, right? How many days backwards the system can go and consume the plan. And if it is in the case of forward, how many days it can go in forward to consume the plan. That is also defined in the number of working days. To illustrate that how this backward and forward is working, right? Here we see some example here. Here there is a planned independent requirement which is maintained here, and there is a plan, right? There is order is booked here. This is the plan there, right? When you enter the order there, then it will go and consume the plan in this backward direction. This is backward direction. We are getting the order, it is consuming in the backward direction, right? That is what the backward consumption is, consuming the plan in the past. Similarly, if we maintain the forward direction, then when we enter this order here, then system will consume the plan in the forward direction in the future. And we maintain the backward and forward, then system will see how much plan is there in the past, it will consume. For remaining thing, it will go in the future, right? Or if it is a forward and backward, first it will see the forward, then go for the backward, right? It may be a little confusing now, right? What is this? This guy is telling something right there. Let us see with some example here now. Before going to the example, let us see that consumption periods are maintained in working days. And sale orders, metal reservations and dependent requirements, they are consumed based on the strategy what we use, depending on the strategy. For example, make to order strategy, make to stock strategy, strategy 10, strategy 50, 63, these things, they will be consuming the plan based on the order or based on the metal issue. These things we discussed during the strategy discussion. Please refer back the strategy discussion sessions. And the customer requirements that are lying outside the consumption period are not consumed, right? That we need to note about it. We have to be careful, and that's why we have to maintain these consumption periods, the backward and forward, very carefully. That should not be too long, that should not be too low. At the same time, if there is no consumption periods maintained, we can only consume the requirements that are planned on the same day. That is option. But in S4 HANA, there is an option. If you don't maintain some value, then system will use the consumption mode 1, that is a backward consumption, and a backward consumption period of 999 days, 999 days it will consume. That is in S4 HANA. And then the allocation of customer requirements to PARs mean that the demand what we enter there, that is carried out dynamically. Dynamically means if there is change in the sale order date, then system will allocate the plan accordingly. If there is cancellation of order, it will allocate accordingly. So it will be dynamic. So you can see the actual situation, what is happening there. Accordingly, if there is any sales order is rescheduled, the allocation is also deleted and redefined. One important point to note, if there are no values maintained for the consumption periods in the material master, then the system will check if there are values maintained in the MRP group customizing. Please remember our discussion on MRP group where we maintain various controlling parameters so they can be applied to the specific material where the MRP group is used. If there are no values in the metal master or in the MRP group, the system will use the consumption mode 1, that is backward consumption only, and the backward consumption period of 999 days. This means that PIR consumption may still happen even if we leave the consumption periods empty, but in the backward direction and backward towards 999 days. So this is a very important point to note. Right, now let us see the example. Let us take one material which is having a consumption mode 2, that is a backward and forward, and which is maintained with the consumption of backward period of 10 days and a forward direction of 10 days, right? Consumption days. This is the plan for each week. Now 10 weeks plans are maintained, 5 numbers per week. Now we are getting an order in week 4. We are in week 4. We are getting an order for week 4 as a requested date. Order 1, 5 numbers. So the plan is consumed here, right? The order is consumed. Remaining plan is not there. It is becoming as a firm order, 5 numbers. The forecast is removed by the firm orders. And then in the same week we are getting 5 numbers. So since we maintain this 10 numbers in the backward days, right? 10 days in the backward, system is going and seeing whether the plan is there. Yes, there is a plan. So it consumes the plan there. So remaining plan is 0 there. Then we enter another order. So we see again another 2 weeks because it's 10 days, right? So it's going back 2 weeks back. So that it will consume like that. Now in the same week 4, we enter another order, right? Same week we are entering another order. What is happening? Now after the backward, now it is going forward. So it is consuming the plan in week 5, right? Next week it is going there and it is consuming. Entering another order, right? All the order we are entering at the requested week 4 only. So first it saw all the backward, now it is seeing all the forward. Now it is consumed. Now when we continue to enter the order 6 with the week 4, there is no consumption there. Why? Because the period is beyond the limit, right? Backward 10 days or forward 10 days. There is no further period, so it will not consume. This is how it will work. Okay. If you want to check this, please put the plan and also enter in the system. Then you enter the sales order along with your sales colleague. Check these things, right? It will be working. And also please note that the ATP and other things are other functions that you have to check. Here we are talking about only the consumption of the plan. Okay. Now we are going to discuss about planning material. So what is planning material? Why do we use the planning material? There are different ways to use the planning materials. One of the ways we'll explain now. For example, we are having a toothpaste, right? This toothpaste may be produced in different SKUs. For example, TP1 with a 50 grams size, TP2 with a 100 gram size, TP3 with 150 gram size. When we want to plan the materials for this toothpaste, its raw materials, then by entering all these individual metals, it may be a lot of time. And also when you're entering the sales plan for these materials, putting together all these plans individually, it may be difficult for a sales team. They will tell this is a toothpaste. For example, per month we are going to produce 100 metric ton or maybe 1000 cartons or 2000 cartons, like they will say. At that time we will plan this based on this toothpaste, which is the virtual material, right? We'll be using as a one material will create like a toothpaste. In that we will link all these TP1, TP2, TP3 materials. So when we plan this toothpaste, all the raw material required for this toothpaste will be planned individually. When you receive order for these individual SKUs, they will consume this plan of this toothpaste. That's how it will be working, right? Let us see that how this is executed in SAP. So we are having the field called planning material. So when planning with planning material strategy are used, this field can be used to enter the planning material. So planning material is a virtual material. It may not be a real one. The demand will be entered for this planning material. So and also the materials like TP1, TP2, TP3 are linked with this planning material in this MRP3 view. So when you receive sale order for this material like TP1, TP2, TP3, they will consume the plan of this toothpaste, the planning material. So this will work along with the planning bill of material. We will create planning bill of material for the toothpaste, right? How to create planning bill of material? Those things we discussed in session 22 when we discussed about the ATO strategy, right? This is mainly used for a push-pull mode. That means based on the planning materials BOM, we will buy all the raw materials, then keep in stock to produce the toothpaste. Based on the actual orders which are coming for the individual SKUs like TP1, TP2, TP3, will be procuring the packaging materials, right? So there is a push with respect to raw materials. There is a pull with respect to the finishing the products. That is a planning material. Planning plant is the plant associated with the planning this material, and also this is where the planning material where we need to have the goods receipt. Then planning conversion factor is if there is unit of measurement which is different between this planning material and the actual material, we can use this factor here, right? Now let us come back to our toothpaste and this TP1, TP2, TP3. So now these TP1, TP2, TP3 individual materials are linked to the planning material in MRP3 view, right? If MRP3 view of TP1, if you take, the planning material will be toothpaste. If you take MRP3 view of TP2, planning material will be toothpaste. Like that, it will be entered there. So we are creating a link. Now for the toothpaste, we will be creating the planning bill of material, where it will be having all these raw materials like fluorides, abrasives, flavors, humectants, detergents, caps like this. At the same time, we'll have a production BOM for this TP1, TP2, TP3, where it will be having its packing tube, primary packing and secondary cartons. So using the planning metal, we'll be, and through planning BOM, which will be discussed in session 22, we'll plan all the raw materials in advance and keep there. So when you receive the actual orders for TP1, TP2, TP3, the packing metals will be planned, right? So how these materials will be linked together, right? So here we are linking them, how the plan will be working. So for example, let us see this plan, right? Week 4, we are on plan of 500. In the first week, in the week 4 itself, we are getting order for 50 numbers of TP1. So it will consume the plan of 50, remaining plan will be 450. Next, we are receiving an order for TP2, 100 numbers. It will consume this plan of remaining 450. So balance plan will be 350 of toothpaste, the TP. Okay. Then we are receiving the TP3 order of 150 numbers. Then that will be consuming. So remaining plan will be 200. So a common plan of toothpaste, which is 500. Now it is formed with these individual orders from TP1, TP2, TP3 for these 50, 100, 150 numbers. So they are becoming the firm sales orders, right? This is how this planning metal and the actual orders are linked, and how the sales orders are consuming the plan of the common material, the planning material, right? So again, I suggest you to go through the session 22 where we had this planning view, how strategy is getting consumed, and also I suggest you to practice this with the examples. And this toothpaste and the SKUs is a very simple example which I shared with you so that you can understand the concept of planning metal and planning BOM. Based on your industry, based on your application, you can use the planning metal along with the right planning strategy like 63 or 50 or 52 based on your need. If you need any specific support, you can write to me in the email what is given in this video. I can help you to set the right parameters. So availability check parameter is having 3 important parameters. One is that availability check. This field defines how availability of material to be checked in different requirements. This is critical parameter which controls how the availability of materials will be checked and which elements to be checked for different functions, because we need to check the availability in different situations like sales order, delivery creation, planning, production order creation, production order release, like that. And also the master scheduler MRP controller should fully understand how availability check is done, how materials are planned, how they are committed for the orders. right? Not only the consultants, but the users also should know how this is working. That is what we will be discussing in this session. And then total replenishment lead time is the time required before the product is completely available, right? That is all the BOM level of materials are procured or produced and made available. Cross object is the indicator that determines if we have a stock of metal assigned to one project stock, whether it can be included into the availability check or not. For that, the cross project is used. If this project is triggered, then we can use the metals which are allocated to other stocks also. So now let us go through the details about availability check and replenishment lead time. What is availability check? Availability check is a process of checking availability of materials or capacity or production resource tools. It is used to ensure availability of materials, machine and supporting accessories so that we execute sales orders, production orders and outbound delivery efficiently and effectively. In general, master scheduling and material requirement planning, they take input from forecast. We know forecast is done based on the future, right, which is uncertain and it also keeps changing. So the proposals coming from MPS, MRP keep changing. The quantities and dates of already existing proposals also will change. In addition to this, we'll get a lot of new proposals. These things, create big surprises through shortages while executing the orders, and also it may lead to a lot of excess inventory if the planned materials are not utilized properly. All these things make it mandatory to perform availability check to serve the customers on time, at the same time to protect the financial balance of the organization. For availability check to be effective, it should be performed in all sequential stages of the order management. So there are three types of availability check. One is the metal availability, and capacity availability, and PRT check. It can be done manually with the specific transactions or automatically with the required configuration which is can be established in the system. Metal availability check is the most important availability check for the planners. Metal availability check is done in different stages of the order management process, starting with sales order, where it can be checked against the plan or available to promise. And then in planned order stage, metal and capacity availability check can be done. During production order, material, capacity availability, production resource tools can be checked. Similarly, during production order release. During delivery creation, we can check the metal availability check. For each stage, different elements can be included as a criteria for availability check based on the need and the criticality of the business process. So what are the benefits of this availability check, material availability check? It resolves shortages issues with more visibility of the information. Also, releasing production order without shortages will help a good management of the materials in shop floor. A productive scheduling with assurance of metal availability. Clarity in shop floor with the clear orders. Reduced follow-up efforts and resources can be used for other productive activities. Proper allocation of metals to the orders. After metal availability check, there is another thing called capacity availability check. So here, when the resources have finite capacity, we can use this capacity availability check. This is performed for short-term capacity planning of resources, which are involved in operations of planned orders and production orders. For production orders, capacity availability check is done both creation and release stage. It involves capacity requirement calculations. If there is constraint, then capacity leveling has to be done. Next is the PRT availability check. Production resource tools may be any of the following, like materials, it may be documents, tools, fixers, or equipment. For PRT items, SAP checks availability through status and master record. That is, availability check for PRT are not just material or capacity, these are static status. SAP will not check whether the same PRT used for other orders also. So you have to be very careful when using the PRT availability check. In this session, we will be focusing on metal availability check. And you are suggested to learn capacity and PRT check on your own and by practicing it. That is not so difficult. If you do the practice, you can learn them. Right? Now, what are the elements of a metal availability check? So we will see what are the supplies which are expected, the expected receipts, that is the inward movements. Then we have available stocks. And there will be requirements, which are the outward movements. All these things will be there with the replenishment lead time. That is the total lead time. What is that? So these are the major parameters. This is overview how the availability check is done. There is incoming, there is outgoing, what is available stock, what is the period. These are the four basic things, right? So the elements of availability check are out to be set as per the S4 HANA. This will be the screen which will be seeing it. We'll be seeing the stocks, where we'll have the safety stock, stock in transfer, quality stock, like that. Then future supplies with the different classifications. Then delayed supply, then requirements, replenishment lead time, special scenarios like this. We'll be discussing all these things individually next. These are defined in SAP through the configuration menu path which is shown here, or the transaction OPJJ. In ECC 6 and SAP S4 HANA 1610, this availability check control field, that settings will be looking like this. Earlier we saw little different. Here this is the screen. Both are the same contents. There is no change in the contents. It is also through OPJJ only. The thing is the version of SAP is changed. Right, let us go through individual elements. First, stocks. Safety stock. Safety stock is what? It is to avoid stock out due to variation in demand and supply. Safety stock is maintained. This is to avoid the fluctuation in the demand and supply. Safety stock. What is stock in transfer? Stock in transfer is expected metals into stock which are moving from supplying facility to receiving facility. For example, stock from one plant to another plant, or from one company to another company. And then quality inspection stock. These are the stock which are received at the plant but waiting for clearance. It is not available for consumption or sales until it is getting cleared. So that is also we have to check, we have to define in the parameters whether to consider or not. And then stocks, we have a blocked stock also. There are some metals which we may keeping in the block stock because of some reasons. Whether we need to consider them as availability or not, we can define. Similarly, restricted use stock. There may be stock which would have moved for some restricted field, but at the same time, should we consider them for availability or not? Also, the stock available with the subcontractors, whether we need to bring them into this availability or not. So all these things we can set through this availability check. And then what are the expected receipts? The receipts may be purchase request and purchase orders. Like purchase request means these are the external procurement proposals. These are planned receipts. At the same time, purchase orders are the confirmed receipts, which means that they are going to come because we already converted them with purchase orders. Also here we can define whether we need to consider the stock transfer order, or we need to consider the shipping notifications or not. So those things we can define here. It's not that only they directly we have to consider purchase orders, but the shipping notifications only we have to consider. That also we can set in the system. The other receipt is the planned orders and production orders. Planned orders are the orders which are, again, these are the planned proposals. They will be changing whenever MRP is running. And then production orders are the firm receipts, right? So we can option to have whether the created production orders or released production orders, whichever we want to include, that also we can include here. And then requirements, like the requirements coming from sales through sales orders, or which are coming from delivery notes. These are confirmed requirements. And there is a stock requirements, stock transport requirements. This is also called as a release order requirement in SAP ECC. Requirements are generated by the stock transfer orders or requisitions to supply the other plant. And these are confirmed orders, which means the stock transfer orders. And the stock transport requisition are the planned requirements. See, why I am telling these planned requirements and the confirmed requirements here is that we need to set accordingly. There are some organizations which may see that we want to confirm only the confirmed orders. There are some organizations will say even if it is planned, it is fine, we want to consider them as availability check, right? So it depends on how the organization is setting it based on supply chain policy. And then further requirements are like a reservation, right? We may create some lot of manual reservations for specific purposes, like metal may be required for R&D or VMI or inspection. So these are the confirmed requirements. There may be dependent requirements which are coming from planned orders. These are planned requirements that also may be considered in plan availability check or not, we can define. And also other thing is with the dependent reservations, which are the reservations created by the created or released production orders, which are the confirmed orders. And also the subcontracting orders and sales order BOM also will be including these dependent reservations. An important parameter is the replenishment lead time. Replenishment lead time is the time required to procure either internally or externally a metal from the date of the order, and it considers the replenishment lead time. How it is there? Replenishment lead time for in-house production will be considered in such a way that first system will consider what is the replenishment lead time defined in MRP3 View. If there is no data there, then system will go and check the setup and inter-operation time, processing time, and GR processing time. These are defined in work scheduling view and MRP2 views. And if the details are not there in work scheduling view, system will go and check what is the details in MRP2 view, right? in which we will discuss this in-house production time and GR processing time. Those things will be considered. These are for in-house production times. For external procured item, system will consider only the planned delivery time and adding with the GR processing time. System will not look this replenishment lead time in the MRP3 view, right? So this indicator is used to confirm the availability check after replenishment lead time in case metals are not available within the replenishment lead time period. Please take a caution here. When we enable this indicator, system will not consider replenishment lead time to confirm the orders. If you need to confirm availability check as per replenishment lead time, we need to uncheck this. For example, if you uncheck this only, system will confirm based on the replenishment lead time. Okay. This one, to understand it clearly, please do some tests. Then only you can get more clarity on this. And then other considerations are like a store location stock. For example, some organizations where availability check should be done at store location level for that metal receipt, outgoing, stocks, those things are to be considered only with respect to the store location. That we can done here. And then delayed supply. And SAP ECC, it is called as receipt from past and future. We can use this option to consider the expected receipt in past or not. If there is the expected receipt in past, system will not consider them. I mean, they will consider, they will give the warning message, right? So that it will be in the past, the receipts are available into the availability check. So it will give a message, right? We can see that. And then the missing parts processing. Using the goods receipt checking period, we can define the period up to which missing parts MRP controller should be informed through email, through the workflow, so that when the missing parts are coming, they will be getting informed. So this is an alert where the MRP controller will get when the missing metal is reaching the plant. And how these things are getting applied. So we saw that the availability check has to be done from sales order, planned order, production order release, and delivery order, right? So here in sales order, system will consider planned and confirmed issues, planned and confirmed receipts, replenishment lead time, and all stocks. Then similarly for planned order, what are the things generally will be considered? For production order, creation order considered, production release order considered, delivery order, what are things considered is given here. These are generally followed approach. So we may vary the settings based on the organization requirement. For example, there are some organizations which will say, I need to consider only the stocks when I release a production order. There may be some organization will say, when I release a production order, I want to check not only the stock, but also the expected confirmed receipts. Some organizations may say that not only confirmed receipt, but I also want to check the planned order receipts. Like that, so maybe the requirements will be changing based on the organization. Accordingly, we can set it. Right. Now we will see how to create the MRP3 views. We starting from the beginning of MRP1, 2, 3. So the transaction code is MM01. So we go and select the material S4 S004 CP1001. So those people, you don't need to create these views again. So we have these views, right, already default. Now we are having MRP3, so we make it as default, selecting all, press enter. Organization details are entered. So again press enter, they are already default. We go inside. So here the details are carried away from other details like description, purchasing group, etc. Because for S04 we have not created any MRP1, 2, 3. It starts from MRP1. So now let us have a reference metal along with this. So we go to /OMM03. Keep TRNG S004, sorry, TRNG CP1001 as a reference to display here with all the views, right? So that we can refer it. So we will start with the MRP1. So what are the details in MRP1? We just refer them. We'll go and update in the S004 material, the material status, and then MRP type. So whenever you put the details, use F4 to see the details so that you get more familiar, and also put F1 to get the help to understand the description of the parameter. Then let us proceed with other parameters like MRP controller, that is S04 here, and then we go to the lot size, which is the weekly lot size, and then what is the minimum lot size quantity, what is the maximum lot size quantity, and also what is the rounding value. Those things will fill. So let us follow the numbers what are the defined in the TRNG, so that when you practice them along with me, you can also understand the results, compare them, how you are getting the results initially. Later you can change these parameters as per your requirement. Now we are going to the MRP2 view. So here we have the details which are to be filled. Let us refer TRNG metal. So in MRP2 we have this backflash production store location and the location for external procurement. Let us fill them here. So production store location 171A, and store location for external procurement, that is also 171A. Backflash we use 1, that is a backflash always, that is a detail we'll use it here. And also we noted the plant delivery lead time and goods receipt processing time. Let us fill those details. So here I forgot the backflash to enter here. So when you are creating, please update it. The S004, when you are create the material, update the backflash indicator. I have forgot to update here. And then when you go to the MRP3, so now here we are having the consumption mode and other parameters. Before that, in the forecasting, there is an indicator as a default will come monthly. I strongly suggest we have to use the parameters W, because this is going to be the consumption values that will be considered by system to calculate the forecast and also the reorder point. If you take monthly, that will not give the right figures, because many companies the consumption is happening mostly in the last week, because billing consumption will be booked more in that week. So it is better to book W. This is what always I suggest. Okay, so we use weekly period indicator here to capture the consumption on weekly basis. Then we go to the other planning parameters like planning strategy, consumption mode, backward consumption, those details. Here I'm going to use the strategy 40 and we'll proceed, because this is what we are going to use for all the metals as of now. Later we'll change the strategy and use in our scenarios. Backward consumption 2, backward consumption period 15, forward consumption 30. Those things we'll use in our test case. See, because we have to see how they are going to behave. Let us use this. And then once you are getting familiar with the fundamentals, then you can proceed. Now we entered all the details. Now we press enter, system will save it and will give the results. Please note the availability check yes or no, it has come as default. We have not entered it because this was maintained in the MRP group of this material or plant parameters. So it is coming as a default, even we did not fill it. So how these details are in plant parameters, when we are discussing configuration, we'll check it. As of now, it is coming as a default SR. Okay. Now we updated all the details. Press enter. See what's happening. System is at the end of the page. So we give yes. So system created this S004 CP1001. So the system will give the message also in the bottom. So now we see that S004 CP1001 created. This is how we are creating the view of the MRP 1, 2, 3 together here. Right? Please practice everything. In MRP3 View, we discuss about forecasting related parameters, common planning strategies, different operating models. Planning strategy, we went into detail about make to stock, make to order, assemble to order. We also discuss on consumption mode and period, what is availability check, and replenishment lead time. So to refresh our knowledge, let us see some quiz questions for this session. So which are the strategy groups used for make to stock? Which are the strategy groups used for procure to stock? What is the difference between strategies 10 and 11? What is the significance of strategy 40? Which strategy was discussed in the session for ETO and MTO? Should we need a plan for ETO, MTO items? What is the replenishment lead time for externally procured items? Period indicator in forecast requirement is used for what purpose? What are the different types of consumption modes? Consumption of PAR will happen only if the consumption mode is maintained, true or false. Availability check is done for materials only, true or false. What is the advantage of assemble to order model? So we'll see the answers in the next session. So the assignment for this session is to create the MRP3 view for all the metals as per the business case. Please refer to the TRNG materials, the respective TRNG materials, and adopt the same parameters so that when we practice the different scenarios, you can compare the results of your scenarios. Then you can also confirm. Once you are familiar, then you can change the parameters as per your requirement. As per understanding various parameters in MRP3 view, we will discuss parameters in the MRP4 view in the next session. Create the MRP3 view of all materials we discuss in the business case. What are the clarifications you need? Please put them in the the comment section. They will be answered then and there. And subscribe to this channel and suggest your friends and colleagues also. Meanwhile, if you like to practice all these metal creations and also scenarios along with me with the dedicated server, You may reach me in the email given here, info@vgrowin.com. Thank you. See you in the next session. Take care. Bye.